Hi, I'm Tom, amateur radio call sign N8FDY, and it's another meter review. This time we're doing the Fluke 289. This is our most expensive meter in this review series. And this is the last of the 50,000 count reviews. Then we'll be moving to the 10 and 20,000 count meters. So, here's what's in the package. I bought this as a complete package. We have the meter. We have the Bluetooth interface. Here is the USB to optical interface. These are not the leads that come with the meter. I upgraded these leads and I sold those leads because I bought a pair of these and used these instead. These are the silicon leads with the retractable Cat 4 protectors. So that way you can't lose them. And of course the super expensive alligator clips. And of course a thermocouple came with it. And here's what I used to open the battery compartment, which I might as well show you now. It's pretty easy to change these batteries. And right now I'm using rechargeables. And as you can see, the fuses are accessible, so you don't have to take it apart to get to the fuses. This did not come with it. I came up with that myself. But what did come with it is a little sheet of paper that had test data on it. They don't call it calibration anymore. Let's see, what do they call it? This is verification test data. Unfortunately, what happened is in the 500 volt range, I found some problems. When we get into the AC or DC voltage, I'll show you that. But it missed its specifications on a few of its measurements in the 500 volt range, which was disappointing, to say the least. Well, let's go into the features of this meter. Third-party safety testing by CSA, 50,000 count, 1/4 VGA dot matrix display with backlight, 15,000 value memory, a special 50 ohm range, true RMS with 100 kilohertz bandwidth, AC plus DC RMS, AC low-pass filter, dBms and dBVs. It can measure up to 500 megaohms. It has a real-time clock to keep track of date and time. The package I bought included the USB PC interface and a Bluetooth mobile interface. In other packages, they are optional. And it has the Fluke limited lifetime warranty. Let's see, we're going to start out with DC volts. We're going to start with 2.5005 and we get 2.5004. 5.0009 and we get 5.0005. 7.5016 and we get 7.502. 10.0015 and we get 10.001. The meter did not meet all its specifications for accuracy as stated in the manual. It was off on the 1 millivolt reading. It was off on the 489 volt reading, and not in this chart, but in the written review, it was off on 3 different voltages in the 500 volt range. The accuracy specifications for the 50 volt and 500 volt ranges were the best specifications in this group of meters, but if the meter can't meet that specification, that kind of doesn't really count. I've measured these voltages and currents and resistances and capacitance with a Keithley DMM 6500, which is a 6.5 digit bench multimeter, which was calibrated in February. And that is what I'm using to compare these meters. Here's the closest I can get to 2 volts RMS on the arbitrary waveform generator. All the AC voltages I tested met the accuracy specifications as stated in the manual. We can also measure AC plus DC, so let's do that. All right, we have 2 volts AC and 3 volts DC. To get the true RMS AC plus DC, you add the square of the AC and the square of the DC, and then you take the square root of that. And that should be 3.60. And that's what we have, 3.6052. So it does do RMS. Now, you notice, even though it has this great graphic screen, there's no way to show you all 3 of the voltages at the same time like they did in the Unity. So that is a little bit of a disappointment. The AC plus DC readings all met the specifications as stated in the manual. The accuracy specifications for this range is the best in this group of 50,000 count meters. Let's do decibels. So we have arbitrary waveform generator generating a 1 kilohertz signal at 0 dBm into a 50 ohm load. We have a meter that's set to measure dBm and frequency, and it's set for 50 ohm impedance. And then we have a 50 ohm resistor terminating the line. And we have negative 0.07. That's pretty close. Let's try 10 dB. 9.97, pretty close. Let's go to 5 kilohertz. Still very close to 10 at 5 kilohertz. Let's try 10 kilohertz. There we go, 10 kilohertz. Let's try minus 20. Yep, minus 20 at 10 kilohertz. So it does a pretty good job on dBm. While we're in the neighborhood, let's do continuity before I forget, because I will forget. Well, it's latched, but not... Well, maybe that's because it's so fast. Let's see. Well, it's not that fast either. So, that's a little disappointing. Let's do some current measurements. Here's 0.89 microamps. Is 0.91. 9.21 microamps is 9.22. 99.0 microamps is 99.02. 131.8 microamps is 131.9. Pretty close. 1.00 milliamps is 1.01 milliamps. 9.98 milliamps is 9.991. 99.4 milliamps is 99.41. All the current measurements I took met the specifications as stated in the manual. The DC current ranges in this meter have the most stringent accuracy specifications of the group. Comparing the accuracy specifications for the voltage and current for this group of 50,000 count meters, the Fluke generally comes in second place, beaten by the Greenlee. The concerning thing is that the Fluke did miss accuracy specifications on the 1 millivolt reading and on 3 of the readings in the 500 volt range. It did have superior specifications to the other meters in the AC plus DC, well, actually tied with Greenlee, and on the DC currents. This has a special low resistance range, 50 ohms. Let's see what the lead resistance is. This is 1.004 ohms, and this measures it as 1.0421. Here's 10.007, 10.032. Now we got to move up to the regular ohm range. And let's see what the resistance of these leads are on this range. All right, here we go with the 100.068. And we get 100.10. Here's 1.0001. And it's over range because we're in delta mode. So let's disable the delta mode and put it into auto ranging. So we get 1.0004. This is 10.002 kilo ohms. 10.006. Here's 100.02 kilo ohms. And we get 100.07. Here's 0.997 mega ohms. And we're getting 0.994. Here's 9.97 mega ohms, and we're getting 9.966. And here is 100 mega ohms. 99.6 mega ohms. 99.7. I have to give credit where credit's due. Out of all our previous meters, this is the only one that can read up to 100 mega ohms. None of the 6,000 count ones I did, and none of the 50,000 counts up to this one could read up to 100 meg. So congratulations, 289. The 1 ohm reading missed the accuracy specifications. All the other resistance values measured met the specifications as stated in the manual. Also note that some of the resistance ranges have the most stringent accuracy in this group of meters. Now it is time for capacitance. This really fluctuates way too much. I really cannot figure out how to roll out this because it's just jumping all over the place. Let's try taking the leads around this way and this way. Let's see what happens. No, it's still jumping all over the place. It is really difficult to decide how to handle this. With all this stray capacitance, there's no way these are going to work, but we'll see. This is 12.36 picofarads. And no, it's negative. It's nope, 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 nope. This may resolve down to 0.001 nanofarad, but it's, as you can see, it's pretty much not very useful. Yeah, maybe my leads are too long, but what makes me suspicious is when I separate them from far away, they still, hey, and it's still just jumping way over. So this is 100 picofarads, 100.56, 100.58, I mean. 100.58, and we're getting, well, it's bouncing around 90. So, I don't know. Let's get into the nanofarads and see what we got. This is 1.005. Oh, and we're out of range. Let us turn off the rail. Thank you very much. And let's go into auto range. This is 1.005 nanofarads, and this guy says 1.13, 1.12, 9.921. Here's 9.921, and that's 10. I don't know. Let's lock it into this range. Let's see if we can zero the leads this way. How much stray capacitance we got going on now? It's still a lot. It still is dancing like crazy. Let's see what we can do. This is 1.005. And we're getting 1.02. Here's 9.921. And we're getting 9.96. 112. And then we got 112.2 and we get 112. Let's see what we do with this 944.5. Well, that's 1 millifarad. That's, well, it's definitely not a 1 millifarad. Okay. I am not plussed by this at all. The capacitance readings that I took on my test bench were a lot more accurate and less jumpy than the measurements I took on camera. So we're going to go by, as always, the measurements on the test bench. And it couldn't read the 10 picofarad, but it read the rest, and it met its specifications as stated in the manual. The high microfarad ranges had the best specifications in this group of 50,000 count meters. Comparing the resistance and capacitance measurements for this group of 50,000 count meters, the most stringent accuracy seems to be the unity for the resistance, and it seems to be the Greenlee for the capacitance. So the Fluke didn't fare that well, but it is probably a solid second place. And it did miss the 1 ohm resistance specification, and it does have the worst high mega ohm specification of the group, so it's a mixed bag. Okay, let's go to diodes. Here's your red LED with the forward voltage. There's your yellow LED with your forward voltage. Here's your green LED with your forward voltage. Here's your Schottky diode. Here's your small signal diode. Here's your rectifier diode. And when it thinks it has a good forward voltage, it makes a little beep. So let's see if I can show you that little beep. All right, that's the little beep. It's not the quietest, but it's not the loudest. Logging. This thing has two ways to log. There's a Bluetooth adapter, which I have, and you can run an application on your Android or iOS device. And the other is it has some software that runs under Windows, and you can hook it up with a USB port from your PC. It's kind of old software. They haven't updated in a while, but it does work. So you also can locally store values and graph the values on this meter. On large data sets, navigating around the graph is much slower on this meter than it is on the Unity graphing meter. Let's go into the pros and cons of this meter. Well, the good parts of this meter: it's third-party safety tested by CSA. It had the best accuracy specification in the group of 5,000 count meters for the high DC volts, the AC plus DC RMS voltage, the DC current, the low kiloohm range, and the low megaohm range, and the high capacitance range. It's easy to access and change the fuses, and it comes with the Fluke limited lifetime warranty. Well, some of the not so good parts of this meter. It did not meet its own accuracy specifications for one reading in the DC millivolt range, 3 readings in the high DC voltage range, and 1 reading in the low ohms range. It also has the worst accuracy specification in this group of 5,000 count meters for the high megaohm range. 6 AA batteries only runs this meter for 100 hours. My conclusion. Well, as much as I love the 87 Roman numeral 5 and the 87 Roman numeral 5 max, and think those are just the cat's meow for 6,000 count meters, unfortunately, this is not the cat's meow of 50,000 count meters. I mean, yeah, I guess when it came out 10 years ago, maybe it was great. Maybe there's something I'm missing since I'm not a pro, but for the price, for what it does, the graphics is kind of slow, but again, it's 10 years old, the design. I know I didn't demo the graphics, but it just was, it's annoying. It's so slow. But, and that's kind of beyond the scope of this, but I mean, if you're buying this, you're probably buying it for graphics, and you'll be disappointed. You know, it does work, but at what price? And it turns out that if you look at the specifications, in the 6,000 count meters, the Fluke 87s were obviously specified much better than the rest of the meters in the bunch, but not here. You know, I would say the least accurate meter, and take that with a grain of salt because they're all have good accuracy, but the least accurate meter, but I still like the meter and going to keep it, was the 121GW. Its AC voltage is more accurate specification than this one. Actually that meter has the best AC voltage specification of the group, and sometimes AC voltage is important and you want to get it right, and it just surprised me that and there's so many other let's see, the Greenlee beats this in many ranges, the Unity matches it in many ranges, even the Bryman 789 will beat this in a few. So it's like, this is not the superior meter like we saw with the 6,000 counts and the 87. It's not, and I'm surprised. But maybe maybe that is not their real market, is the higher end meters. Maybe it is the the best of the 6,000 counts, but everything else, well, they do make lots of other things and lots of other measurement equipment that is not related to what I'm interested in, and again, it's more for professionals. So I would steer you away from this meter. If you want a graphing meter, I would seriously look at the Unity 181A, which we reviewed just a little bit ago. So I'm sorry to say that for me being a Fluke fanboy, I'm not a fan of this meter. I don't even know how to quantify it. I just don't like the meter. It's just, I'm going to sell it. And I'm going to take a loss, that's for sure, because, I went and bought the big kit that had the USB and the Bluetooth and their software, which, what amazes me with all these meter companies is their software is so old. They never seem to update it. And there's got to be bugs in there, because whoever met software that didn't have bugs? And they don't update it. Anyway, I hope that helps. If you love a 289, I'm sorry, but I don't like it. Oh, let me show you the one thing that drives me crazy all the time I was testing this. You have it here like this, and I had meters on the left or right of it, and I was trying to adjust it to get it just right, and I'd be adjusting it, and next thing you know, it does that. None of the other meters here do this, and you gotta sit here and figure out how to shove this back on, and I mean, you really gotta push this sucker to get it back on. Okay, and all right, so I got it back on. You'd say, okay, fine. So you go and you're doing it and you're playing with it and you're adjusting it to make it match the other meters, and it does it again. It is crazy. That I understand why they did it, because it's really convenient to open up the battery compartment if you take this off. But I showed you earlier, or maybe I didn't. Yeah, I think I did. I showed you how to open it already with this on. So, I mean, this alone would drive me crazy with this meter. And the black and white screen, the slow graphics, the fact that it doesn't show 3 numbers for the AC plus DC. It's just, there's a lot of things. So I'm going to keep the Unity 181 for my graphing meter, and I'm going to sell this guy. And I wish I would have paid attention to the reviewers who told me not to buy it. But, I got to learn for myself sometimes, and I'm kind of stubborn. And I figured, well, how could Fluke go wrong? Well, all right. Anyway, I hope this helps you out. The next video coming up, I'm going to stick all 5 of them out here and show them to you. But this is Tom, N8FDY, saying 73 and take it easy.